Hey, what's up, 8th grade? Mr. Catlin here, helping you out with lesson 3 and lesson 4, piecing these two together in the same one since we did them in class at the same time. We have 3 different ways to equivalently write 10 to the 4th power. We can multiply it out and actually get the value that it is, 10,000. We can show that it's the same as 10 to the 1st times 10 to the 3rd, because now that we know we multiply these exponents, we can add those together to get 4. And then, like we learned in class today, we can take a power to a power, and that those 2's actually get multiplied to show that that's 4. So let's do something similar with 10 to the 6th power. Let's represent it in, 3 or 4 different ways. Let's start with an expanded version of it. So 10 to the 6th power, writing it as a different way, we could expand it out to being 10 multiplied by itself 10 times, right? That's one way. That's equal to 10 to the 6th. Let's do it as its actual number. If we do 10 to the 6th power, it's just the number 1 followed by 1, 2, 3, 4, 5, 6 zeros. You could get that from any calculator that does exponents as well. Another way to express 10 to the 6th, let's try it using multiplication. Let's break down 6 into factors of numbers that multiply. Not factors. Let's break it down into um, parts of a sum that add up to 6. So 2 numbers that add up to 6, like, say, 2 and 4. When we break that down, based upon our rule, we add those together, we should get 6. So this would equal 10 to the 6. What I was about to say was let's break it down into its factors, which would be like 2 and 3, 6 or 1 and 6 backwards. Let's do 2 and 3. We can also use 2 and 3, the factors of 6, to build an expression that uses our exponent rule, that when we take to an exponent factor, sorry, I wrote the wrong thing. When I take it to an exponent factor, then those actually get multiplied to give us 10 to the 6th. So 10 squared raised to the 3rd power is 10 to the 6th. And we'll do one more that we learned today, which is a setup for a division problem. And let's start with, say, we have 10 to the 10th power. What would I have to put down here to get 10 to the 6th? Well, I need a number that subtracts from 10 to give me 6. And that number for me would be 4, since I had 10 minus 4 would equal 10 to the 6th. You subtract when there's division involved with exponents. You add whenever there's multiplication involved. You multiply when there's an exponent to an exponent. And then, of course, you can see the expanded and regular versions of these numbers. These are just some ideas that you can roll with as you write many different expressions for the value of 10 plus 6. All right, and as we finish up, why is this equal to 10 to the 11th power? Why does this expression show that? All right. To explain or show our thinking here, I believe we need to write this out in expanded form. All right. 10 to the 15th power is the same as having 15 tens on the numerator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 tens in the numerator of this division problem. 10 multiplied by itself 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. And we're dividing that by 10 multiplied by itself 4 times, as you can see by this expression. So this is like the expanded version of it. I am definitely showing my thinking instead of explaining it. Now, whenever we have this set up, a 10 divided by a 10, that's going to cancel and equal 1. This 10 and this 10 is going to cancel and equal 1. As are these and as are these. So these 10 factors, or these 4 factors of 10 that were in the denominator, are going to essentially eliminate 4 of the 10 factors that are in the numerator, leaving behind only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, leaving behind only 11 tens that are there in our answer, right? And so that's one way that we can think about it. Another way that we can show is that we have a rule for this. The rule says if we have 10 to the n power divided by 10 to the n, then to express this as a single, we can just subtract m by n, and we'll have it. So here we're just doing 10 to the 15 minus 4 power, and that's where we're getting 10 to the 11th. So a couple of different ways that you can visualize it and use the rule to prove that this is correct. They're taking the 4 away from the 15. That's all I got for you guys today. Tomorrow we don't have a quiz, but we will be working on some of these ideas of working out these problems with our exponential rules and maybe making a little bit of a competition out of it. We'll see you guys later.